Solving systems that involve fractions or decimals. We've kind of seen this before, and there actually is a way to handle it that may be better than what we did. But what we want to do is get rid of the fractions or the decimals. So step 1, let's call these 1 and 2 so we know what we're doing, is find the lowest common denominator, which is 6. And so we're going to multiply equation 1 by 6. So 2 goes into 6 3 times, right? 3x plus 3 goes into 6 twice, giving me 4y. And this will be negative 12. And multiply equation 2. Actually, no, I should have just done that over here. 3x plus 4y equals negative 12. In equation 2, 4 and 3, lowest common is 12, so this will be 12 times y, right? 12 times s. 4 goes into 12 3 times, so that's equals 3x, and 12 goes into 3 4 times, so we get 4 times 5 to be minus 20. So we're going to have the equations 3x plus 4y equals negative 12, and 3x minus 12y equals, and the 20, right? So the 12 comes over and the 20 goes over there, so equals 20. This is very nicely set up for solving by elimination. So we're going to subtract. That gives me 16y, right? So 3 minus 3 is 0. 4 minus negative 12 is 4 plus 12 is 16. Negative 12 minus 20, so negative 32. And y is negative 2. Substitute in the y of negative 2 and solve for x. So in this case, I'm going to break the rule. We're going to go back here and just do it here. So it'll be 3x plus 4y equals negative 12. So 3x plus 4 times negative 2 equals negative 12. 3x minus 8 is negative 12. Oops, forgot the x. 3x, so add 8 to both sides, is equal to 4. So x is 4 thirds, and the solution is 4 thirds and negative 2. Okay, so how are you going to verify that? Well, you know what? Let's just plug it in the calculator. So equation 1, we're going to go with 4 thirds divided by 2 plus 2 times negative 2 is negative 4 divided by 3, and the idea is, hey, is that going to be equal to negative 2? No, it's not. So 4 thirds plus 2 3 minutes in. Alright, didn't check. Why not? Okay, this should be negative 4, 3x, so x will be negative 4 thirds. Now let's try. That's why we check. So second enter, and let's just back this up, and we'll insert a negative, and we get negative 2. Huzzah! And now what else do I want to do? A quarter of x, so 1/4 times negative 4 thirds minus 5 thirds, and that should be equal to y, which is negative 2, and it is. So that's why we check. So if we make a mistake, we can go back and figure out what the mistake was and fix it. Decimals. To get rid of decimals, actually pretty easy. Just multiply through by, in this case 10, move the decimal point over, right? So if these were 0.03 or something, hundredths, then I'd multiply by 100. So everything is nearest tenth. So if we multiply by 10, it's going to give me 5x plus 3y equals 2. And this will give me 3x minus 6y equals negative 30. Call that equation 1. Equation 2, we're going to solve by elimination. Let's multiply equation 1 by 2. Whoops. So 2 times equation 1 is 10x plus 6y is equal to 4. And equation 2 by itself is 3x minus 6y is negative 30. We're going to add because these have opposite signs. So we get 13x is negative 26 and x is negative 2. And again, to solve, let's go back to 1 of 1 or 2 because again, we're just going to check anyway. So 5 times negative 2 plus 3y equals 2. Negative 10 plus 3y equals 2. 3y, let's see if I can do this right. So I say the answer is negative 2, 4. And to check that, let's just drag over. 0.5 times negative 2, 0.5 times negative 2 plus 0.3 times 4, so that should equal 0.2. 0.3 times negative 2 plus, minus 0.6 times 4, and that should equal negative 3, and it does, so there's my check, right? So if you're not asked to formally verify, you should still verify, right? I mean, I had this wrong initially, so you've got to still verify. And then a little bit of practice for you here with some fractions and that to practice your fractions, and we'll post the answer for that. This has just been a short little blurb on solving systems that involve fractions or decimals.